Howdy. In this demonstration, I'm going to continue on the last two, which were covering different topics related to Git. And so in this demonstration, I'm going to focus in on collaboration using Git and remote GitHub repositories. So again, the focus this time is collaboration and remote repositories. I'm going to say just quickly kind of what the high level structure of remote repositories look like with respect to local ones. So here, if you here and your local machine is everything from the anatomy of a GitHub repo. So this figure gets dropped in here. It's on your local machine, so we're kind of like zooming out in a way. And then over here we have some GitHub repo, and you can see that the GitHub repo actually doesn't have as much stuff as your local repo does, and that's because it's what they call a bare repository, so it doesn't need a working directory or anything like that. It's just the repo, and basically there's your main concern is just transferring data between your local repo and the remote repo. And so those are what the main commands are about, is just transferring data back and forth. One little quick thing I'll point out in the local repo is that you have these things called remote branches, and basically they're all colored red here, notice. And so one little thing about those is that your local repository at least knows about the remote repository, although it doesn't always know exactly what the state of the remote repository is, but it can retrieve some state information. And it saves these remote branches locally, which are basically kind of like read-only records of what it thinks is on the remote, or what the last thing it saw on the remote. And so what you see here is origin/origin/origin/. So origin is a name for the local name for the whatever remote GitHub repository that is. They just call it origin locally, and so this is referred to as a bookmark. And again, that kind of gets at the fact that it's kind of just a read-only placeholder for what's really on the remote repository. And then you can see they have a master branch on the remote, and they have some other branch right here. And then they also have this head one, which is kind of weird because we have a notion of a head, which is the thing checked out. The head remote branch is actually just like the default. If you were to open the GitHub page, which branch would it show you? And so that's what the head is. And so basically on the remote, the head probably mostly follows master, but you can probably reset it. And so that's what that's about. So anyway, so the remote branches become important because when you are thinking about your repo, you're thinking about it in relation to the remote, but the reality is what you're really working with is local copies of things, which can be updated as things change. So the other thing I want to say is, because this is focusing on collaborative tasks, I'm going to go ahead and introduce two developers, Alice and Bob, and they're going to be the ones who perform a lot of the tasks. And I'll just mention real quick that I have things set up for each of them. So for example, they each have a GitHub account. So there's Alice, and then I have Bob's GitHub account open over here. So there's Bob. And so they each have GitHub accounts. They also each have a terminal. Alice is green and Bob is blue. I've set up a virtual machine for each of them. And so it's kind of like they're on separate computers. They have their separate GitHub space. And so in this way, I'm going to use this to simulate multiple developers collaborating on different machines and using GitHub to do it. I've gone ahead and fired up their VMs, but I haven't SSH'd into them. So let me just go ahead and do that just to get things started with them. So I'm going to say vagrant SSH for Alice. And I'm going to say vagrant SSH for Bob. And so now Alice is logged in, and now she's going to cd into her workspace folder, and Bob is going to cd into his workspace folder. And each of them we can look, there's not really anything in there at the moment. Okay, so so the first thing I want to do is set the push mode. This is one of those things you have to do one time. It's a global configuration setting, basically. And so Alice and Bob, I haven't done this for them yet, so I'm going to go ahead and do it. Basically, what we want to do is set the push mode to simple. There are multiple push modes. It usually has to do with when you're pushing, which branches are getting pushed. And so Git is is their default. The default, they sort of change this over time, and the default they want to go to is the simple version, which that's the one we'll do. And I believe it means just push the current branch. I think that's what it means. But anyway, that at least seems to work. If it's doing more than that, that's probably fine too. And so anyway, so also the motivation for setting this is that it will, every time you push, it'll give you a lengthy warning message until you actually do set it. So might as well get rid of those warning messages now. So I'm going to have Alice run that command, and I'm going to have Bob run that command. Okay, so they've both run it now. All right, let's talk about sharing local repo on GitHub. So say you've created your local repo, like I did in the previous two demos, and so you want to share that on GitHub. So in a web browser, and I'm going to do this using my own account, and then I'll share it with Alice and Bob. So I guess I'm on the team too. And so in a web browser, I'm going to create a new repository on GitHub, and the repository does need to be empty, so I'm not going to add anything else to it, just going to create an empty repo. So I'll go to GitHub, and I'll go to this organization, and here's the new repository button, and I'm going to call this Git demo, since that's what I've been calling the one. I use the same name I used locally in the previous demos. I guess I will make this public, I guess, in case you wanted to look at it. But no checking this, no setting this, not going to initialize with anything. If you do these, then you'll have stuff in your repo, and we want to keep it empty for now. So make a public one, that's Git demo. And so, okay, so we have now created an empty repository. And so if we go back here, the next thing we want to do is follow the instructions given on the repo page regarding how to share an existing repo. And this is, I'll just cut over to it. So what we have down here are some instructions for different ways to populate this repository. And what we really want to do is push an existing repository from the command line. So this is the command we want to use. And so if I go to my terminal, I'm still in my virtual machine from the last demo, and in the workspace folder, and specifically in the Git demo project folder. And so, for example, I have a project in here. It's clean. The working directory is clean currently, and I can take a quick look at what's there, and you can see that. So we have a history here with a little bit of branching. There's just one branch, the master branch currently, and that's the one I'm on because the head's pointed there. Okay, so like I said, I'm gonna copy this, and then I'm gonna paste, and it actually got 2 lines, and so the first line just runs, and the second line I have to hit enter to make run. So notice the first command is git remote. So there's a git remote command for managing remotes. I'm gonna add a remote. I'm gonna call the remote origin, and then here's the URL associated with that remote repository. Then I'm going to go ahead and push to that origin repository. I'm going to push my master branch. And this -u basically means that the master branch is going to be a tracking branch. My understanding of tracking is the tracking branch notion is still just a little hazy, but I gather it has to do with the fact that these two branches are going to be kept in sync between the two repositories, or to put it another way, they kind of mean the same thing between their two repositories. So that's why we run that. So go ahead and run it. And there it pushes all my files over there. And so if I go look, if I go back to here, well, let me see what this is now. Okay. If I go back here and I refresh, you can see now the project has been added. There it is. Okay, so so the next thing the instructions, the demo here says to do is we're going to go ahead and just review the state of the local repo and giving special attention to the remote branches that have been added. So, so remember up here, we just looked at the repo and there were no remote branches anywhere, right? It was just the master branch. So now if we rerun that, now we have synced to a remote, and so now we have a bookmark for origin, and it's we have a local, essentially local copy of what's on the master branch. It's all synced up though, because they're both the same. No changes have been made. So the other thing I want to do is add my collaborators here, Alice and Bob. And so recall Alice's account is SDF-Alice, and Bob's account is SDF-Bob. And so when you're administrator on a project, you have access to the settings, and you can go to collaborators and teams, and of course it wants you to do a little extra authentication for that. And if I type in SDF-Alice here, adding as a collaborator, I can select her and add. And now Alice is going to have write access. And I can do SDF-Bob as a collaborator, add collaborator. And now Bob has. So one thing is that they get sent email invitations, and I have email accounts wired up for them, but I'm not going to go do that. I'm just going to, since I'm local here, I'm just going to copy the invitation link for Alice, and I'm going to go to Alice's terminal, and she should be logged in. We'll see. Yeah. So here I'm logged in as Alice in this browser, so I can accept the invitation. And so now Alice can open this, has this open, and let me grab Bob's invitation. Might be the same actual link. And I'll open a new tab here and let Bob. So Bob here is what Bob would see, so he can accept the invitation. Okay, now Bob has write permissions to this. Okay, so I've shared my remote repository. My collaborators can see it and they can push to it. And so next up is connecting and syncing to an existing repository. So we want Alice and Bob to be able to do some work on this. And so they're both going to perform these steps. So first step is in the web browser, open the repo page. Yep, Bob has it open, and so does Alice have it opened. Then each of them is going to click the clone or download button and copy the secure HTTP URL for the repo. So it's the same for both of them. The URL is the same. So I'll just go ahead and copy it one time here. Copy. Okay, so I've copied it. And then each of them in the local terminal, in their local terminals, they're going to clone the repository using git clone. So the way you do that is here's Alice. We're in her workspace folder. We're going to say git clone and paste in repo. And so now she has a copy. And we're going to have Bob do the same thing. Okay, so now Bob has a copy. You can see the Git demo folder there. And Alice has a copy. You can see the Git demo folder there. So review the state of the working tree to see that it's downloaded. Well, I just showed you that, yes, Alice can see it and Bob can see it. Perhaps it would be sensible to cd into it. So Alice will cd into git demo. And then notice, this is a Rails thing, but a Ruby thing, because notice we have RVM configuration stuff set up, so it automatically set up the git demo workspace, and it selected Ruby 2.5.1, which I previously installed on here. And so Bob is going to also cd into git demo, and he gets a similar result. So, so there. The other thing we can look at for each of them is the state of their repositories with attention to the remote settings and branches. So let's look at the, we'll do the big git log graph one line all decorate. And so you can see that looks, okay, so Alice has the full version history with the master branch, with the being the branch we're currently on. She also sees the remote origin master and origin head bookmark and whatever read-only, essentially read-only versions of the branches. Incidentally, I noticed that earlier that for some reason on the on mine I don't see the head. I have to think about why. There's probably a good reason for that, and I'm not entirely clear why that is. We'll go ahead and run git log graph one line all decorate. Okay, and you see Bob has basically the his own identical copy of this. So he's got a copy of the repo. Alice got a copy of the repo. Everybody got a copy of the repo. Okay, so now let's say we want to push some changes to the repository. So let's let Alice do that. And so the first step here is to make changes to the working tree. I guess what I'll do is kind of like I've always done. I'm going to open in Alice's browser a tab which is on the host OS right here in her folder, and I'm going to open in VS Code the demo project. So this is now Alice having the demo project open, and so she's going to modify it a little bit. And so the way I'll have her modify it will be simply to clean up this README file. So she'll just delete its contents, leaving the heading on it. And that's the change she'll make. Now she'll go ahead and stage and commit her changes. To stage them, oops, I'm in the wrong terminal. Back. Okay, now I'm back in the VM. So to stage them, she'll say git add dash big A, git commit dash M. We'll say updated. Okay, so she staged and committed. We can look at how the state of her repo has changed following that commit. And so you can see that here's Bob's version, which is what she had earlier. This was the latest commit, and now that latest commit, that commit is here, and there's a newer commit associated, which is on the master branch. And so notice that origin master has fallen behind. So the master branch on the remote is fallen behind Alice's. And so in order to catch it up, Alice is going to go ahead and push to that branch. So she'll just say git push. That the whole doing origin master, git push origin master, and with the dash u, you only need to do once at the beginning, and thereafter you can just say git push. And this is Alice. Okay, so Alice has pushed now. So so again, we can look at hers, Alice's view of the repo, and now hers is now origin master, for example, is caught up with her version. Now notice that Bob's will not have changed. We can run it here to see. Yeah, he's still back on this FCB commit, which is now here, and Alice's has the most up-to-date version. So Bob's version has fallen behind even the remote. And in the remote, we can actually open it in a web browser and see how it's changed. And so really any of us can do that, and it should look the same to all. So if I go, this is using my account, if I go here, you see, well, it's the README, right? So updated README 16 minutes ago. So that was Alice, I guess. And then if we go to Alice's view and reload it, you can see updated README 16 minutes ago, and even Bob can see it in his view, because we're basically all looking at the same remote repository just through different web browsers, right? So so that's that. So Alice has pushed a change to the remote, but Bob is still behind. So now we need to talk about how to pull changes when changes come into a remote, how to pull changes. Oh, also notice, I'm going to mention quickly, that was a fast forward merge case where Alice was able to, when she pushed, it was just a fast forward. And so similarly, this one is also going to be a fast forward merge, only this time we're merging into Bob's code, but it's also going to be a fast forward merge, because he hasn't done anything. So let's actually look at this. So for Bob, let's see how the state of his repo, view the state of his repo to confirm that it's out of date. And so we kind of did that before, where we look at the state of Bob's repo, and indeed we see that his last commit is here, and the current one should really be this commit. And so Bob is going to fetch the changes from the remote repo and merge them into his local repo, basically to get himself up to date. Now it's kind of interesting, there's git pull will do this, and because Bob hasn't changed anything, if we look at his tree here, he hasn't changed anything since the last time he saw master branch. This is going to be a trivial merge, which is also called a fast forward merge. And he can do that with the git pull command, which is the one you're going to normally use. It is kind of like a two-step thing, but for now I'll show you it as the single step. So Bob's going to say git pull, and so there he goes. So he pulled the README file, updated, and now we can review the state of his repository to see that it's up to date now. So now here was what he previously had as the latest, and so now he's downloaded the new commit, and he's had his master branch adjusted. And again, this was a fast forward merge. There was nothing. It was because he hadn't changed anything since he last got the remote version. It was strictly just a simple update to get him caught up. There was nothing complicated about merging. So now we'll talk about how to push changes to a remote repo when you have a merge conflict issue. And so this is a common scenario that you need to know how to handle when you're collaborating using remote repositories. So we're going to start by having Alice make some more changes to the working tree. And so let's have Alice start a contributors section in the README, and she'll put herself in it. And so we'll save that. And now we'll have Alice stage and commit her changes. So Alice is going to say git add to stage them. And you're going to say git commit added contributors to README. Okay, so she staged and committed them, and so now in parallel, Bob's also going to be working on this project, and so he's going to also make changes to the working tree, and his changes, well, we don't have an editor open for Bob, so let's get one open for him. So I'm going to open a host OS terminal, and for Bob, I'm going to open the project. So it was git demo. Okay, this window here is Bob's window. We may get confused because Bob's window and Alice's window look very similar. But this one's Bob's. You can see he's still empty for him because he doesn't have Alice's copy of things. And Alice hasn't even shared it yet. So say that he has the same idea. And he goes ahead and adds himself to that. And so so that's the change he makes. And so he's going to go ahead, and he's happy with his change, so he's going to go ahead and stage and commit this too. So back on Bob's VM, I'm going to go add dash big A, git commit dash m, added contributors. He actually even says the same commit message. Maybe he should say it a little differently. I'll say added contributors section to README, just to make these two distinguishable, at least a little bit. Okay, so Bob's gone ahead and committed. And so now Alice is working a little faster than Bob, so she is going to have gotten around to pushing her changes to GitHub. So she'll say git push. And so notice that push completed successfully. So her changes now are uploaded to GitHub. And if you want, we can just quickly confirm by reloading the GitHub view, and we can see the README says added contributors to README, which was what Alice had done. And it also shows her was the last person to contribute to this. Okay, so next up, Bob is going to attempt to push his changes. However, this command is going to fail with a merge conflict. So we go to Bob, and Bob's like, I would like to share the changes I just made. And so he logs in. And now he gets a different message than Alice. So he gets rejected and then failed to push some refs, and then updates were rejected because the remote contains work that you do not have locally. Yeah, the stuff Alice just pushed. This is usually caused by another repository pushing to the same ref. You may want to first integrate the remote changes, for example, using git pull, before pushing again. Okay, and so yes, so Bob got stopped there. So what Bob needs to do next is it was just that flat out failed. So he's like, oh, okay, I need to fetch the changes from the remote repo, merge them into my local repo, and the way to do that is using, at least as a first step, is using the git pull command. Now there's probably still there's going to be conflicts here because they were editing the same lines in those in that shared file, in that README file, and so the auto merger won't know what to do. So he says git pull, and of course it attempts to auto merge the README, and a conflict comes up. And automatic merge failed, fix conflicts, then commit the results. And so the next thing Bob's going to do is actually go manually fix those merge conflicts. So, and if he wants to be reminded ever of where they are, he can just always say git status, and it'll say, okay, unmerged paths in the README file. So we need to go to the README file. So I'm going to go back to Bob's editor. So here's Bob's editor. And indeed, now look at what got added. We got these the separators, and he sees, oh, I see, we're both trying to put our names in the contributors. Notice that they both added the contributors line, but because it was the same thing they added, then there's no conflict. It would just keep the line. It's only here where the text differed that it's a problem. So Bob says, okay, I know what to do with this. We'll just keep us both in the list. And I'll let Alice's name come first to be alphabetical. Okay, so Bob saves the file. And so now the next thing he's going to do is stage and commit these changes, since that was all of the merge conflicts he got. So he's going to say git add -big a, git commit -m, and then again, always struggling for a good log message for these sort of merge things, but we'll go with that one. So there he commits, he now has the merged thing committed locally. And so finally, Bob is going to go ahead and push changes to the remote. And this time it should complete without error. Before we go run the git push, let me go ahead and run the log view just so we can look at what the state of things are. So, so here was the last version of the remote that Bob saw. And here was his version of the remote. And so you can see that merging the pull and then the editing and the committing produced this merged version of these two versions. So this was the remote's Alice's version, and this was Bob's local version. Now this one is the merged version of the two. You can also see that according to the last thing Bob saw from the remote is this is still where the remote's master branch is, and so he's going to need to catch up the remote. If the remote had changed again, there would be need for more pulling and more merging. But since the remote hasn't changed, he should be able to just push this, and it's just a fast forward merge, right? Because all you have to do is move up origin master to this commit. So he's going to go for it, git push. And he's Bob. And he pushes. And so finally, Alice now is out of date. And so she'll want to do a git pull so that she can have the local changes. For this last step, for this very last one, I'm gonna, I mentioned earlier that git pull is actually kind of a two-step process. It's a fetch, so basically download the changes, and then a merge the changes in with your stuff. So I'm actually gonna go ahead and do it as a two-step process for Alice, and hopefully it'll work fine. So here I am over on Alice's machine. When I look at her view of it, it's outdated. This is the latest version she knows of. To her, she thinks everything's up to date. But if we look at Bob's view, we see that what is hers? 3.6.2. So here's her version. So Bob has a newer version, which he's now pushed. And you can see also on Bob's side, it's showing that everything's up to date. So so Alice's information is out of date. Now, if you always if you want the latest information about what's on a remote, you can use the command git fetch. This won't actually change your local commits. It just downloads the README kind of like read-only reference version of what's on the remote. And it also is a way to tell your local repository what the latest state of things are. So Alice says get fetch, and something happens. And so now if we run her thing, we see here's her master branch, and now she does see, oh, there is a new commit on the remote, and here's where the remote's master branch is. So I am behind the remote. I could run one of two things here. I could just run pull, and it'll do a fetch and then merge. And that's really mostly how we do it, but it is also possible to say get merge, and then it would be, we're picking a branch, and since this is a read-only branch, we're going to bring it into our current master branch. So I believe this should work. And it's a fast-forward merge, because all she had to do is move hers up. There's no branching changes there. And so now if we look at the graph, we can see hers matches up perfectly with Bob's. So like I said, most of the time we use git pull, but it is possible to do them as two distinct steps. Download the new commits and the updated remote branch information, and then do a merge as a separate step. All right, and so that concludes these first introduction to Git and how to do version control on the local repo, and how to do branching, and also how to do some collaboration on the remote repo. Coming up, maybe in a few demos, I'll get into some of the more complicated workflows that developers like to use for remotes, which have some nice things about them, but are also kind of more complex than this. So this is kind of like the simple way to collaborate using remotes. Just having basically kind of like a shared master branch, which you use as your main way of exchanging versions. So anyway, I hope this was helpful, and hope you have a great day. Bye.